So we're going to be talking about centroids and orthocenters today. These are our next two and last two centers of our triangle. So centroids are made from the median of a triangle. Okay, and a median is something that goes from this vertex to the midpoint of the opposite side. The centroid of the triangle is the point of concurrency of the medians of the triangles. So nothing funny happened out of this, but your concurrency theorem does get you that the point from the vertex to the point of concurrency, your centroid, is 2/3 of the entire length. So on the front of your notes, I want you to put that this is 2/3 and this is 1/3. Now that does apply for the entire thing. So this is also 2/3, this is 1/3. And you're like, oh, I have to work in thirds. Not always, because you'll be able to figure out how to work with it. Because think about it. 1/3 is this much. So if you know how much XF is, you could probably figure out how much BX is by just multiplying it by 2. Because 1/3 times 2 is 2/3. All right. Altitudes of a triangle. The altitude of a triangle is created from the perpendicular segment from a vertex of a triangle to the line containing the opposite side. And you'll typically see this, especially when you're learning Pythagorean theorem or when you're working with right triangles. You'll also see it when we get to trigonometry. The orthocenter of the triangle is the point of that concurrency of the lines that contains all the altitudes. This is the only point of concurrency that can be inside, on, or outside of the triangle. And that's going to be the case when it's typically a right triangle. You can do that. The concurrency of altitudes theorem, it just says that they're concurrent. Nothing special, no math. The orthocenter just kind of doesn't make sense. Sticks out a little bit. All right, determine whether XY is a median, altitude, or neither. So remember that a median goes from the vertex to the midpoint of the other side. All right, and an altitude, it just hits it at a right angle, so it's perpendicular to the opposite side. For number 1, we're going to see that this is a right angle, and it's hitting it from the vertex to the opposite side at a perpendicular, so it's altitude. Number 2, even though it's splitting it in half and at a perpendicular angle, it's not a median or an altitude. It's neither. And number 3, goes from your vertex to the middle of the opposite side, so it's going to be your median. Okay. I do want you guys to start getting used to like looking for these, but also just going back and noticing, hey, this is going to be an orthocenter that I'm working with. This is going to be a centroid that I'm working with. You're going to want to be able to recognize all 4 centers of the triangles. Right? So the first thing we're going to do is this one. If CD is 21, what is the length of CE? Well, we use our congruency statements, and we know this is 21, which means this is also 21, so the entire thing is going to be 42. All right, if AG is 26, What is the length of AD? So I want you to remember that AG is going to be 2/3 of AD. And you can sit there and we can do the math and do 26 is 2/3 of AD. Multiply it by the reciprocal on both sides so we can get rid of this fraction. And then you're doing 3/2 times 26. And then you get, let's see, I'm going to do it this way first. You get 39 is AD. That was a lot of work. I do need you to know the math behind it, but there's a trick to this too. If AG is 2/3 and GD is 1/3, you could figure out the entire whole. This is AG is 2/3. That means half of it is going to be 13. And that's going to be that 1/3. And 26 plus 13 is also 39. So it doesn't matter how you do that part, but just know you can use those relationships to help you. I do want you to see that you're able to do this, just because sometimes you're going to get like x plus 3 as a choice, and you need to be able to solve for x. So know that you might have to use the reciprocal method. I want to clear this up a little bit so we can keep going. All right. If CF is 75, so this entire thing right here is 75. What is the length of CG? So, again, that's going to be 2/3 and 1/3. Well, let's do 75 divided by 3. We know that gets us 25 because, well, we know our relationships with quarters. And then it's 2/3, meaning it's going to be twice that 1/3, and it's going to be 50. So this would be 50, and this would be 25. And that's the same thing that would happen if you were multiplying it by your fraction. All right, now let's go ahead and do this last one. If BG is 17, what is the length of GE? Well, like we said earlier, this is 1/3. And this is double that length because it's 2/3. So 17 times 2 is going to get you 34. All right, you're just going to have to remember that it's 1/3 and 2/3. Or if you just remember one of them, that small bit is 1/3, you'll be set. All right, this next one, your brains all probably just went, oh my gosh. I have to combine everything that I've learned into this one graph. Yup, you do. And you'll be okay. Now, you want to remember that an orthocenter is doing it at a perpendicular, right? It's making that right angle. So let's look at line MP. Since that's a horizontal line, the point from N, that's an altitude with MP, is this one, because it drops down vertically. Then from M all the way across to NP, you're going to have to find the opposite slope of this. The negative reciprocal, opposite reciprocal, if you remember that. So I'm going to put the thing down, and my slope for this is 2/1 for NP. That means if I want to make it perpendicular, I'm going to put it down, flip it, and reverse that sign. So my slope is going to have to be a negative 1 over 2. Oops, sorry, that was a negative 2 to begin with. So that should be a positive. And then we can do 1, up 1, rise, up 1 over 2. And then lastly, we have to do it for point P here, and it has to be perpendicular to line MN. So if we look at the slope of line MN, we're going up 4 to the right 1. That means a perpendicular slope is going to be, I'm going to put the thing down, flip it, and reverse the sign. So negative 1 over 4. So 4.2. Now that point of concurrency is this point right here, 5, 3, because that's where all 3 of those perpendiculars intersect. All right. So we're going to flip to the back. You have 3 more examples that we're going to work on. All right. And you should be able to breeze through these a whole lot faster. All right. So if PB is the centroid of JKL, that means automatically you need to mark it up because you'll want to remember that centroid is with medians. That means M is the midpoint of JK, N is the midpoint of KL, and O the midpoint of JL. All right. With all of that done, you get JK is 22. All right. If I know JK, that tells me about JM and MK. Or in this case, KM, which is going to be 11. And I believe that's the only other thing that I can figure out. Okay, so got that one. Let's do the next one. You've got KN is 13. Ooh, okay, so this part is 13. That can give you NL, which is 13. It can also give you this entire thing, which is going to be double that, so that's 26. All right. OL is 18. All right, so same thing. You can figure out that JO is 18 because it's congruent. And the entire segment would be 36. And guess what? Using all of that information, you were also able to figure out if they were to ask you the perimeter of this. And the perimeter of this, of course, you would just be adding 22 plus 26 plus 36. If they asked you for the perimeter of triangle JKL. All right, but of course, I'm not necessarily asking you that, but I want you to be prepared just in case, hint, hint. No. Should be 84. All right, let's do this next one. If H is the centroid of BDF, so mark it up. No, one too many there. All right, DF is 50. Well, that means DE and EF are going to be 25 apiece. CF is 42. Well, that means CH will be half of that. So it'll be 21. Right? Oh, wait, that's a lie. I have it backwards, guys. So what they're saying is this entire segment here is 42. So we're going to have to do 42 divided into 3 parts. And when you do that, you get 14. So CH is 14. And 14 times 2 is then going to be that 28. All right. And look, we've also got CH in there, so we can fill that in. And I'm going to switch colors again. All right, so last one is BH is 22. And that's from this vertex to our centroid, which means that's 2/3. And then this is our 1/3, meaning it's going to be half that, which is 11. So HE is going to be 11. And if I add up the entire thing, this thing's going to be 33. All right, last one. We've got our number 3. Now can you determine if it's a median, altitoid, or perpendicular bisector of triangle ABC? So you'll notice the right angle. That means it's going to be either an altitude or a perpendicular bisector. And it can be multiple of these. So the first one that we see right away is yes, that it's a perpendicular bisector. So PB, yes, because it's bisecting it at a perpendicular. It is also the altitude because it's hitting it across the way. And it's doing it at a 90-degree angle. And then the median, it's going from the vertex to the opposite side to the midpoint. So this is yes, yes, yes to all 3 of them. B. And that's the thing, right? Before we talk about B, is that these segments can be perpendicular bisectors, medians, and altitudes all at the same time. All right. B is not a perpendicular bisector. It is an altitude, just because it's hitting it at, oh, well, look at that. It's not even that. Because your altitude should be going more like this, where it's hitting it from the vertex to the opposite side. So even though it looks like it, it's not. All right? And that means it's also not going to be a median because it's not bisecting the other side to begin with. This is none of them. If you want to write no instead of the X's, because that sticks out for you better, you are more than welcome to do that. All right. So this one is not a perpendicular bisector because it's not bisecting at a right angle, but it is bisecting it from the vertex, so it's just a median. And because that right angle is not there, we cannot even consider that it is an altitude. So you have to realize, if something is a median and an altitude, then it can double up as a perpendicular bisector, or triple up if you want to get technical. All right, this is not going to be a perpendicular bisector because even though it has that right angle, it's not bisecting AC. It is an altitude, however, because it's hitting it at a right angle. And going back to what we were talking about earlier, the median it's not being intersected halfway, so can't make it happen. All right, thanks for watching.